Okay, so when we're counting things, the number of an event A happening, or then we're going to be counting and adding together all the different ways it could possibly happen. So let me start with this with examples of 3-digit integers that are divisible by 5. So I've got ends in 0, or ends in 5. Okay, so 3-digit integers. Again, I'm going to do this, lots of little lines here to kind of write down the choices. So if I have put the 0 here, right, there's one way to put the 0 here, and there's one way to put the 5 here. Okay, so now let's go figure out what else I can have. So remember, if I'm making a 3-digit integer, this is not 0. But I already put the 0 here, didn't I? So I don't have to worry about that. So how many choices do I have here for 3-digit integers? So I guess this isn't distinct or anything. So, but it isn't 0 here, so that means there's 9 choices here, and these are not distinct digits or anything. So there's 10 choices here, and that's me putting the 0 here. Okay, so I put the 5 here. And so that means there's one choice for that, and then there's 9 choices here, because again, this cannot be 0, right? And then I have 10 choices here. So 90 plus 90, so 180 different numbers between, or that are 3-digit numbers that are divisible by 5. Okay, so now let's move to bigger numbers and distinct digits. So again, I'll let you do this one for Zoom. So think about ends in 5 and ends in 0. And then this one, this was going to be a trickier one. So has the digit 3 once. So what I'd suggest is that you think about all the different places that you could put 3. 1, 2, 3, 4. So I would say pick the case where you put the 3 here. And then 2, 3, 4. Then you put the 3 here. So I'll let you finish that off. Okay, so if I have a pen with 4 symbols and I could choose between letters and digits, so that's going to be 36 to the 4th, right? So 4, and I've out of these number of choices, 36 for each of the 4. So how many pens can I have with no repeats? So 36 for the first, 35 for the second, and then 34, and then 33, right? So this would be for the 4 different, what do you call them, symbols that you're picking. So there's no repeats. Okay, so this is a big deal. I want you to make sure you really use this. So if I want how many pens there are with letters and digits with at least 1 repeat. Okay, so this is really useful. So to get at least 1 repeat, you want to say, okay, let's find the ways to do all of them and subtract off no repeats. So what does that give us? 36 to the 4th is all of them. Subtract off no repeats, that's what we just did here, right? So I really want to make sure you get that. All right, so then here, what's the probability that it contains at least 1 repeat? So probability is the number of favorable over the total number in the sample size. So that's 36 to the 4th. So the numerator is 36 to the 4th minus, right, all this multiplied together. Okay. So let's look at telephone numbers. Actually, I'm going to have you do these. I'm going to be leaving lots of these for you to do, so you have practice. Okay, so let's look at the numbers 1 through 999 that have no repeats. So I'm going to go through, but because there's different digits, the other idea. Oh, no repeats. No, that's right. And at least 1 repeat, I want to use this. Okay, so at least have no repeats. No repeats. So let's do 1-digit numbers or 2-digit, right? Or 3-digit. Okay, so how many different 1-digit numbers have no repeats? Well, that's 0 through 9. So there's 9 of them, right? Okay. or 2-digit numbers. Okay, so here's my 2-digit numbers. Remember, this cannot be 0 if it's going to be a 2-digit number. So that means I have 9 choices here, and then whatever I chose here, I can't use here, so there's 9 choices here. Or 3-digit numbers. So again, this can't be 0. So there's 9 choices here. And since whatever I chose here, I can't use here, so there's 9 choices here. And then I've got this 3rd digit, so I've chosen 2 numbers already, so there's 8 choices for the last one. And let's see, I'll just figure this out because I want it for the next question. So this turns out to be 738. Okay, so how many integers from 1 to 999 have at least one repeat? So that's all of them. So 999, subtract 1 plus 1. So that's 999 is all of them. Subtract 738. So there's 261 that have at least one repeat. All right, so let's do this. This one's a little challenging, so let's do this one together. So if I have a license plate that has 0 to 3 letters, so it could have no letters or all the way up to 3 letters, or it could have no digits or all the way up to 4 digits. So I've got letters and I've got digits, right? So the choices for letters could be 0 letters, so there's 1 choice for that. There's choices for letters, there could be 1 letter, so 26 for that 1 position, or it could have 2 letters, so 26 squared, or it could have 3 letters, 26 cubed. So these are the letters, and it has digits, right? So there's 1 choice for no digits, 10 choices for for 1 digit, 10 squared choices, right? 10 cubed, whoops, I made my parentheses too small, or 10 to the 4th, right? So this is letters and digits, okay, but no blank plate is allowed. So you would never multiply all this out, but by when I would multiply this out, this would be no letter and no digit, so there would be 1 in there that would be the blank plate. So then I have to say, okay, subtract that 1. A little tricky, huh?